All right, welcome to Unit 2, Lesson 4 on 1D projectiles. This is the second and last example problem for this topic. And this question is based on the moon. Now, a little bit of info that it gives us is that the moon has 1/6 the gravity of Earth. And it also lets us know that if we toss a rock up into the sky, the total time for it to come back down to its release height is 18.4 seconds. The goal of this question is to determine how high the rock went. All right, seems pretty straightforward. So let's jump right into this here. Starting with a blue marker, I'm going to sketch a little diagram. So we have a rock that's going to go up and come back down. So here we have the going up, right? It's going to start from here and come back down. Perfect. And the total time that this takes to go up and then come down is, what did it give us here? 18.4 seconds. That's handy. What we're looking for how high this thing went. Okay, so that's our displacement. D is equal to question mark. Yeah, let's write out our variables and see what we can solve here. So I'll put down we have a few things right away. Acceleration, we have to do a little calculation. Let's do negative 9.81 meters per second squared divided by 6. I chose negative because, again, our initial velocity is upwards, so we're going to have up as positive, down as negative. Its acceleration is equal to negative 1.635 meters per second squared on the moon. Okay, our time. So similar to example 1, we're going to assume that the time it takes for it to go up is going to be the same as the time it takes for it to go down. There's some symmetry here. And so this value of 18.4 seconds, if we're just looking for the upward displacement, it's only going to be half that time to go up and then the other half to come back down. So to go from bottom to top, this is 18.4 seconds divided by 2. So really our time works out to be, is it 9.2? Yep, 9.2 seconds. Okay, we've got 2 or 3. We need to find one more. What else do we have? Well, the last one is sort of a hidden piece of information. And you should be getting these by now. We've done these actually in class a couple times. But the very first topic, I believe, I may be mistaken, says that when we have maximum displacement, we're going to have velocity of 0, or vice versa. Final velocity of 0 means maximum displacement. So at the top, right at the top of this thing, as this ball is going quickly and slowing, pauses at the top momentarily. That's max displacement. And this has at the top a final velocity of 0. So I'm going to put VF is equal to 0 meters per second. Okay, 1, 2, 3 values we now have. We can solve for whatever we want. Turns out this question wants us to solve displacement. So I'll put delta D is what we want. And it leaves us with what? VI is equal to, we don't know, but we also don't really care. Okay, let's find an appropriate formula. This question has actually quite a nice formula that's going to do some canceling. It makes our work real nice. The formula that fits this is delta D is equal to VFT minus 1/2 AT squared. Okay, since our VF value is 0, right, this thing here is 0, this whole term cancels out to 0 because anything times 0 is 0. Let's cross this whole thing out. And rewrite this formula to delta D is equal to negative 1/2 AT squared. Cool. Plug numbers in and we are done. Be careful to watch symbols. This negative symbol is going to be important. And our acceleration value being negative is also going to be important. So we're going to say delta D is equal to negative 1/2 times acceleration, negative 1.635. I'm not going to put units on in this question. Times t squared. Time again, right? It's just time getting to the top. The time going up and down, we just use that half of that value to get the one way. So it's going to be 9.2, not 18.4. 9.2 squared. Many people forget when they're punching this into the calculator to square that. Don't forget the square. Give yourselves little asterisks or stars or highlighted on exams when you're punching these into the calculators. I take many half marks off for people who miss the squared symbol. Easy marks you don't have to lose. Okay. Delta D, once it's punched into the calculator, I get a value of 69.2 meters. There we go. And that's the final answer. This thing goes 69 meters high. We can check sig digs really quick. I think we had 3 the whole way through. This really should be 3, right? Because we started with the 18.4. So I didn't give myself enough here. But we are good. That's the answer.